Hello, everyone. Let's continue the remaining part from lecture 7. So we're dealing with series, and now it's time to deal with summation over the elements that belong to a series. Okay, so the series is a sequence that is summed. If this is the sequence A1 followed by A2 followed by A3 until AN, so a summation, it's written as its associated series is A1 plus A2 plus A3. So it's a summation over all elements inside the sequence. Okay. Okay. So this could be written as, here is the sample for the summation. We use this to denote summation to, here is A1, A2, A3 until AN. So I will generalize as A subscript J, where J, this is a starting boundary, starts with 1 until it reaches N. So it's every time you substitute with J is 1, so you'll get A1 plus. Increase it 1 by 1 until you reach N. So second value is A2, third value is A3 until it reaches a subscript N. So this form is exactly equivalent to adding all the elements of the of the sequence. Okay. So use the summation notation to express the sum of the first 100 terms. So, okay, sum from J or I or anything. So this is the index. A is 1 until it reaches 100. So this is a summation of 100 elements of the sequence AJ, a subscript J, where it's equal to 1 by J. So I'll sorry. If I'm gonna use the notation for the index being denoted by I, so I will replace here J by I. So I will write it I 1 by I. Or if you're gonna use the notation for the index being written as J, so I will represent the element of the sequence by the same form which is given 1 by J. Okay, Shabab. So here is the representation to represent when J is 1, 1 by 1 is 1. When J is 2, so it's called 1 by 2. When J is 3, it's 1/3. When J is 4, is 1/4, and so on until it reaches 1 by 100. Okay, Shabab? So this form is equivalent to the form on the left. حلو جدا. So now we have this form. How can we calculate it? It's very easy by substituting with all the values. So here is the summation for I square, starting with I with 1 until it reaches 5. So just substitute from the boundary and increase it until it reaches a maximum value. Okay. So the lower bound here, it's I is 1. The higher bound, I is 5. So substitute with I is 1. So it's 1 square plus I is 2. It's 2 square plus I is 3. Keep increasing I until it reaches the higher bound. 3 square, 4 square plus 5 square. So here is 1, here is 4, here is 9, here is 16, here is 25. If you add all of those, you'll get a result, which is 55. So this is equal to 55, okay? Okay, so again, summation for this. In the bracket, substitute with I is 0, 1, 2, 3, until it reaches 4. So it's equal to, when I is 0, so this is 0 plus 2, plus. When I is 1, so this is 1 plus 2. When I is 2, so this is 2 plus 2. When I is 3, so this is 3 plus 2. When I is 4, this is 4 plus 2. So it's equal to 2 plus 3 plus 4 plus 5 plus 6. So here is 10, 15, 18, 20, sorry, yeah, 20. Okay. So same here. So it's equal to, substitute when I is 0. So this is twice 0 is 0 minus 1. I is 1. So 2 times 1 minus 1. So this is 2 minus 1. Plus, when I is 2, this is 4 minus 1. When I is 3, this is twice 3. This is 6 minus 1. When I is 4, this is 8 minus 1. So this is minus 1. And here, 2 minus 1 is 1. 4 minus 1 is 3. 6 minus 1 is 5. 8 minus 1 is 7. Add all of those together. So this is removed with this one. Minus 1 removes 1. So the remaining is 15, ya shabab. So this is exactly the result of the summation of twice I minus 1, starting from I0 until it reaches I4, okay? So we can also write the summation in different notation. So you can just say the sequence is A subscript N, where N starts with M until it reaches K, like for example. Here, like for example, a sequence is A subscript J. So I can write it in many forms. I can write it as AJ, summation for AJ, where J starts with M until it reaches N. Okay? So AM and the one after is AM plus 1 until it reaches A subscript N. Or I can write the boundary condition just next to the terminals of the summation here and here, and it would be the same situation, the same calculation. Or I can just say summation for AJ, where J is greater than or equal M and less than or equal N. It's also means the same meaning, ya shabab, okay? So all of those three different forms represent the summation of the elements AM plus 1 until it reaches A subscript N. So also, if you have a set for J, and you can just say, this is a summation of AJ where J belongs to the set S. So set S contains a set of all the indices. So like, for example, here, if S is a set of 2, 5, 7, 10, sigma AJ, where J belongs to S, it means substitute with the first element, A2, substitute with the second element, A5, substitute with the third element, A7, substitute with the fourth element, so A10. Okay, shabab? Okay, great. So also, shabab, we can just say here, this is another example for a summation, which is an infinite summation, starting with 1 plus 1 by 2, 1 by 3, 1 by 4. So generally, I can write it as 1 by J, where J starts by, J is the denominator now, from 1, and it keeps increasing until it reaches infinity, ya shabab, okay? It could be this way. So the summation is a closed form representation for a sum of a series. So can we calculate this value? Yeah, of course we can. Sigma to minus 1 to the power of k, where k starts with 4 and ends with until it reaches 8. So it's minus 1 to the power of 4 plus minus 1 to the power of 5 plus minus 1 to the power of 6 plus minus 1 to the power of 7 plus minus 1 to the power of 8. So minus 1 to the power of even number, it generates positive 1. Minus 1 to the power of odd number, it generates negative 1. So here positive 1, here negative 1, here positive 1. So positive 1 cancels negative 1, positive 1 cancels negative 1. So the remaining is 1, ya shabab, as a result, okay? So we need to be able to calculate a given submission, and this will be in the exam يا شباب like this form. Okay, can you calculate this part? Yeah, of course. Summation of j square, where j starts with 1 and ends with 5. So it's equal to 1 square plus 2 square plus 3 square plus 4 square plus 5 square. 1 square is 1, 2 square is 4, 3 square is 9. Here is 16, here is 25. You know, this summation, it could be written as, because you start with the lower bound, j is 1. If you want to start with a lower bound, j is 0, instead of having j is 1, it's okay. So you will shift the lower bound and the upper bound by 1. You will decrease it by 1, both of the two boundaries. So the boundaries, the new boundaries, it could be j starts with 0 and ends with 4. And now, because I decreased the boundary by 1, I need to compensate it inside the value which will be summed together. So how I compensate it? If you decrease the boundary, increase the expression with the same value. So j decreased by 1. So here the j should be compensated by adding 1 over it. So instead of having j squared, this j will be replaced by j plus 1. So it will be all squared. And if you're not sure about whether the two summations are exactly the same or not, we have calculated the one on the left. Let's substitute on the one on the right and check whether it gives the same solution or not. So starts with j0. Here, substitute 0 plus 1 is 1 square, which is 1. So the next j is 1. 1 plus 1 is 2. 2 square is 4. The next j is 3. 2. 2 plus 1 is 3. 3 square is 9. The next j is 3. 3 plus 1 is 4, and 4 square is 16. The last value for j, it's 4. 4 plus 1 is 5, and squared to be 25. So if you notice now, this is the same result as the exact value for the original summation. So it's viable to shift the boundaries, but if you shift the boundary, you need to compensate what's inside the submission. اوكي يا شباب، لو هنقص الباوندري بمقدار 1 اروح على كل جي جوه السبمشن وازودها بمقدار 1. طب لو هزود الباوندري بمقدار 1 اروح على كل جي جوه السبمشن وانقصها هي بقى بمقدار 1 علشان الاديشن بتكمبنسيت السبتراكشن اللي حصل. اوكي. And here are the closed form representation for some submissions. You can use those in the cheat sheet. So like, for example, submission to Q, starting from K is 1 until it reaches N, it's exactly the same as N squared times N plus 1 all squared by 4. So those two values are exactly the same, okay? Okay, and also here is a notation for the product. So this is the notation for the summation, adding things together, and this is a summation for multiplying things together. It's called pi. Product over aj, starting with jm equal m until it reaches n. So it means aj substitute by m now, j is m, times, and next j is m plus 1. The next one is a subscript m plus 2 until it reaches a n يا شباب. Okay, so this one is used to represent the summation, and this one is used to represent the product يا شباب. Okay, okay, and this is the end of the remaining part that was left in lecture 7. Thank you very much and good luck.